So transformations of exponential functions work just like the transformations of most of the other functions that we've looked at. So vertical translations, you can move your function up and down by adding k or subtracting k from the function. You can move your function left and right by adding or subtracting h from the x. And so here's some examples right here. If we put a negative sign out in front of that function, that'll reflect it over the x-axis. We could also reflect it over the y-axis if we multiply the x itself by -1. And of course, we can stretch it and compress it vertically. And there's a couple of examples for you right there. Let's look at this example that's already been done for us here. It's g of x, and we're told that g of x is equal to 2 times 3 to the power of x minus 5 plus 2. So let's break this down and look at the pieces of our function here. First of all, it has a base of 3. So that means the parent function of this exponential function would just be f of x equals 3 to the power of x. So how have we changed that parent function here? Well, this first 2 is going to give us a vertical stretch by a factor of 2. When we subtract 5 here, that actually moves us 5 right. That's a translation. And when we add 2 at the end, that is a translation 2 up. So that's what we have right here. And you can tell that just by looking at your function. I used a calculator to get some values for some points in a table, and then I used those points to create this graph in Desmos. See, here's the points from my table plotted on that graph. Take a look at h of x. Just by looking at this function, what can you tell about it? Pause the video for a minute and write down everything that you predict about the graph of this function, then hit play again. So here's what I can tell. I can tell that my base is 1/3, so the parent function would be f of x equals 1/3 to the power of x. This has been translated 1 to the left because I added 1 to my x value, and it's going to be reflected over the x-axis because of that negative out in front. Now use a calculator to figure out the corresponding values of the function for these values of x. So complete the table using a calculator. So here are the values that I found using my calculator. Now let's plot them on the graph. And there they are. Now one thing to be careful of here is they look like they're touching y equals 0, but they're not. They're just getting very close. There's an asymptote right there. So I'm going to connect these points as smoothly as I can, and it'll look something like that. So now I have a basic picture of what this function would look like, of what h of x would look like. Why don't you pause the video and see if you can do the next one entirely on your own. When you're ready to see the answer, hit play again. So the only transformation here that we have is that we've translated this graph 3 units up. So this one's really pretty simple, and its parent function would be f of x equals 2 to the power of x. So I've listed some ordered pairs here, and let me put those on my graph now. I can see that the last one there, 259, is not going to fit. That's okay. So now that I've plotted these first 4 points, I can just draw a smooth line best as I can through them. And there I have a basic picture again of my function of m of x.